Welcome to the Explainer. Okay, let's dive into this. Today, we're looking at a highly rigorous culinary science experiment. Consider me your mission commander, briefing you on how to pull off what a lot of folks honestly thought was impossible in the kitchen. We're going to walk through step by step the exact science of the Cryo-S'mores air fryer protocol. So here's the big question. Can a scoop of ice cream actually survive a 400-degree Fahrenheit convection fan? I mean, on the surface, that sounds like a recipe for a massive, sticky disaster, right? Because air frying ice cream isn't just some fun little baking hack. It's essentially a desperate, high-stakes race against thermal transfer. You are literally fighting the mechanics of your own appliance to protect a highly vulnerable payload. To pull this off, we've got some strict mission parameters to cover. First, we'll identify the threat. Then, Phase 1, the foundation. Next up, Phase 2, Cryo-Stasis, followed by Phase 3, the thermal shield, and finally, Phase 4, the flash fry. All right, let's kick things off with Section 1, the threat, which is, of course, thermal transfer. Our ultimate antagonist here is the convection fan itself. So the crucial point is exactly 60 seconds. That's the tight timeline we're up against. If you were to just toss a bare, unprotected scoop of ice cream into an air fryer, the intense heat from that fan is going to melt it down into a useless puddle in exactly 60 seconds. Time is absolutely not on our side, and honestly, neither is the environment. Which brings us to a massive engineering trap that a lot of beginners fall right into. On one hand, we've got what the source material brilliantly calls the base cracker delusion. Sure, it might look like your traditional s'more, but a flat graham cracker provides absolutely zero lateral support. As the ice cream inevitably starts to soften, fluid dynamics just take over. That ice cream is going to slide right off the sides and coat your air fryer basket in a complete nightmare of burning sugar. No thanks. That's exactly why we strictly require a containment vessel. A mini pie cup acts as a literal retaining wall. It secures the payload and makes sure your dessert actually remains, consumable. So to survive this 60-second threat, we have to build what we are officially defining as a s'mores pod. Listen, this isn't just a snack. This is a thermally shielded containment vessel designed specifically to toast the exterior while keeping its ice cream core perfectly frozen. We're actually using the laws of thermodynamics to insulate the center from all the fiery chaos happening on the outside. Which brings us to Phase 1, the foundation. Let's review the exact payload ingredients we need for this sublayer. We require 4 mini graham cracker pie crusts. Make sure they're the pre-made 3-inch tart size so we get the correct retaining wall height. You'll also need exactly 1/4 cup of fresh organic blueberries, 1/4 cup of diced organic strawberries cut very small, and exactly 1 ounce of roughly chopped 85% cacao dark chocolate. Okay, let's move to execution and see how this all builds together. Step 1 is super straightforward. Just divide your berries and cacao evenly into those 4 pie cups. But step 2, that's where the science really kicks in. You have to bury this payload at the very bottom, completely beneath where the ice cream layer is going to go. The physics behind this placement is absolutely vital. See, 85% cacao has very little sugar, which means it has a remarkably low burning threshold. If it gets exposed directly to a 400-degree fan, it's going to instantly turn bitter and ashen. And the berries? If they face that heat, they'll boil, release all their water, and completely ruin the structural integrity of your graham cracker crust. They've got to stay hidden. Moving right along to Phase 2, Cryo-Stasis. Now, what's really interesting about this is the strict limitation on our primary ingredient. The protocol mandates premium, high-butterfat vanilla or chocolate ice cream. It specifically warns, do not use low-fat or diet options. Why? Well, it's all about water content. Diet ice creams contain way more water, which turns into ice crystals in the freezer. And those ice crystals melt significantly faster under high heat than the dense, rich fat you find in premium ice cream. So in this experiment, butterfat is literally a survival mechanism. Here is the strict assembly protocol for our core. Step 1, you're going to scoop a very firm, round ball of that high butterfat ice cream directly onto your berry and chocolate payload. Step 2, press it down slightly so it physically locks into the cup. You're engineering this to have absolutely zero air gaps at the bottom. Getting rid of those gaps is vital for the structural integrity of the pod. Then, Step 3, initiate a mandatory cryo-freeze by getting those loaded cups into the freezer for at least 2 hours. And I really want to stress this exact requirement: 0 degrees Fahrenheit or minus 18 degrees Celsius. These pods absolutely must be rock hard before they can even think about facing the convection fan. If you try to rush this step, the whole mission just falls apart. Next up, phase 3, the thermal shields. Once that core is frozen solid, we have to wrap it in insulation. Luckily for us, marshmallows are made mostly of trapped air. Because air is a terrible conductor of heat, it creates the absolutely perfect scientific insulation for our pods. But remember, the air fryer fights back. We've got the disaster of the blown-off failure to worry about. If you try to just balance standard marshmallows on top of your ice cream dome, that powerful convection fan is going to blow them right off, leaving your ice cream completely exposed to destruction. That's why we use the vastly superior solution, Marshmallow Fluff. Think of the fluff as an industrial culinary adhesive paste. The fan literally cannot move it. If you absolutely have to use whole marshmallows, you've got to microwave them for 3 to 5 seconds to melt them into a sticky state. But honestly, Fluff gives you the best structural security. When you pull those rock-hard pods from the freezer, you have to act fast. Step 1, immediately coat the entire exposed ice cream dome with the marshmallow fluff. This is so critical. The marshmallow must firmly touch the edges of the graham cracker crust all the way around the perimeter. If there's even a millimeter of a gap, boom, you've created a thermal breach. Hot air will penetrate that breach and instantly melt your core. Step 2, press a 1/4 cup of crushed graham crackers directly into the sticky marshmallow layer. This forms a really tough protective exoskeleton. All right, we've made it to phase 4, the flash fry. The pods are built, the shields are up. This is the final and honestly most dangerous stage of the mission, utilizing high-velocity convection. Treat this concept with the gravity it deserves. We are not cooking, we are executing a controlled surface burn. That perfectly describes the violent nature of what is happening inside the air fryer right now. We want to sear the outside at rapid speed, way before the heat even has time to realize there's ice cream inside. To achieve that burn, you have to follow this urgent timeline exactly. -5 minutes, you must preheat the chamber to a blistering 400 degrees Fahrenheit. Do not skip the preheat. Seriously, if you put the pods into a cold air fryer, the slow rise in temperature gives the heat plenty of time to penetrate the core, which means total mission failure. At 0 minutes, place the frozen, completely sealed pods directly into the hot basket. From there, you watch them like a hawk. Somewhere between 2 to 3 minutes, the exact moment that marshmallow fluff puffs up and turns a toasted golden brown, you extract them immediately. Mission accomplished. If you followed the protocol, you get to experience an incredible contrast of temperatures achieved entirely through careful food science. And this brilliantly illustrates what we've been working toward. You break through a shattered, warm graham crust and gooey toasted marshmallow, down into semi-melted, intense dark chocolate and perfectly warm berries, only to discover a perfectly frozen, untouched ice cream core right in the center. It's basically a masterpiece. This brings us to the end of our explainer, but I want to leave you with a thought-provoking question. Now that you've totally mastered the Cryo-S'mores Protocol, what other impossible desserts will you attempt to air fry? Think about it. You now understand the deep principles of thermal barriers, fluid dynamics, and structural engineering right in your own kitchen. Take this knowledge, go experiment with your own payloads, and keep pushing the boundaries of what's actually possible.